Hello again, my magnificent math students. Today we're going to start solving some equations that have absolute value in them. But let's first review just what absolute value is. So absolute value looks like these bars that are on each side of a number, and it's really just asking how far it is from zero. It's not saying the opposite of your number. So this answer is not going to be -5. This answer is just going to be 5 because I'm asking how far is 5 away from 0? It's 5. How far is -13 away from 0? 13. So these absolute value answers are always going to give us positive answers when we are evaluating them. So the absolute value of 2 is 2. The absolute value of -11, how far is it from 0? 11. The absolute value of 7 is just 7. And the absolute value of -4 is 4. You should also be able to compare numbers that have absolute value on them. So for instance, in number 1, the absolute value of -82, that's just 82. The absolute value of 57, again, not negative, that's just 57. And 82 is bigger than 57. So we would get a greater than sign on that one. I don't think we need to do all 6 of these. However, I do want to mention on number 6, the absolute value of -61 is positive 61. The absolute value of 61, also 61. Those two are going to be equal. So again, today, the new stuff, and this will be new. So far, we've done a lot of stuff that you saw last year. I'm sure you did. But solving absolute value equations, this is new. So an absolute value equation is just an equation, has an equal sign, and it has absolute value in the equation. This other vocabulary term, extraneous solution, today won't really matter to you. But in the next lesson, that is going to come up, and we'll remind you about that. But an extraneous solution, notice it says extra at the beginning here. It's a solution that looks like it's going to work, but it doesn't really work when you try it. Okay, so it's an extra solution that doesn't work. When we get absolute value problems, sometimes we'll get answers that look like they should work, and when you substitute it back in because of the absolute value, you might have to say, oh, nope, I can't use that one. Just some basics about absolute value. For number 1, this is saying when I take the absolute value of any number, doesn't matter if it's positive or negative, when I take the absolute value, it won't be negative. It'll be bigger than 0, or it could be exactly equal to 0, but it won't ever be negative. It won't be less than 0. For number 2, if I have the absolute value of 2 opposites, the absolute value of -a or the absolute value of +a, that should give me the same answer, just like that -61, +61. Absolute value is the same because they're the same distance away from 0. In number 3, if I'm taking the absolute value of 2 things that are getting multiplied together, I could also split them up and just say, I'm going to take the absolute value of each number and multiply them together. It gives me the same thing. And the same kind of thing happens for number 4. If I have a division, those fractions really are just divisions, I could do the absolute value of the numerator and the absolute value of the denominator to give me positive answers on both of those, and then go ahead and do the division. And remember, this is just saying, hey, I'm not trying to trick you. Nobody can divide by 0, not even Albert Einstein. The other part of this looks a little bit scary because there's just so much stuff here. When we're solving equations, we know that the absolute value of anything is going to be greater than or equal to 0, right? So it says that it's equal to C in this problem, and I'm saying C can't be negative, okay? When I do this, though, the way that we solve absolute value equations is we're going to write 2 separate equations and have to solve both of them to get our answers. And you really do have to solve them both because it's not just going to be like 5 and -5. You'll have to get 2 different answers. So I would say this stuff that's on the inside, that could be equal to just a regular C, or that stuff on the inside of the absolute value could be equal to a -C, because if I would take the absolute value of it, it would still give me this positive that I have right there. Okay? Also, they will try to trick you sometimes today. And if I give you an answer or a problem where C is less than 0, so if C is negative, I'm going to get no solution. Because if I take the absolute value of anything and I get a negative number, so let's say that this is -3, that can't happen when I take the absolute value. It's going to be positive. So I get a no solution, which is, remember, that sign. So here's how this is going to look. When I have a problem like letter A, I'm going to solve the equation, which really means I'm going to have to write 2 separate equations. And then sometimes it's going to ask you to graph it. So I'll show you what that looks like. So if I know that x minus 4, the absolute value of that is equal to 6, that means that this stuff that's on the inside could be equal to positive 6 because the absolute value of 6 would be 6, or it could be equal to negative 6 because when I do the absolute value, that would also give me a positive 6. So when I write this, I need 2 separate equations. I'm going to say x minus 4 equals 6, or x minus 4 equals negative 6. And then I have to solve both problems, right? You know how to do that. I would have to add 4, and 6 plus 4 gives me 10. And then if I would do the same thing in the other equation, add 4, ooh, this is not negative 10. Negative 6 plus 4 is negative 2. But I want you to check those answers just so that you can kind of see what's going on here. If I put the 10 back into this original problem right here, 10 minus 4 is 6, and then the absolute value of that is 6. If I put a negative 2 in there, I would have negative 2 plus a negative 4 is negative 6. But the absolute value of that is still 6. So they both work. So 10 and negative 2. Most of the time in absolute value, we get 2 answers. The graph for this is a much more complicated graph than what you really need, and I'll show you what I would expect to see on this. But negative 2 was my smaller answer, so that answer got graphed right there. And then the 10 got graphed right there. Right? It doesn't matter which order you get your answers in, but on a number line, the smaller numbers go on the left, the bigger numbers go on the right. Just something to point out to you, the 4 that we had in the original equation, x minus 4, that's like the center of our absolute value. And then if I would go 6 units away, which was this number right here, going 6 units this way is what gets me to the negative 2, and going 6 units that way is what gets me to the positive 10. Okay, this is one of those problems that I said they're going to try to trick you. I have the absolute value of 3x plus 1 equals negative 5. When you see a problem, you're going to want to write down 2 equations right away. However, because that's negative, remember I said if I'm going to take absolute value, I can't get a negative answer. No solution. And our symbol for that, remember, is that guy right there. You don't need to show any work on this. If the absolute value is by itself and it equals a negative, it's a no solution. Okay, number 1, and I would suggest that you probably write some of these down as examples so you've got them for when you're doing your work. Number 1 is the easiest problem you could possibly write for absolute value. And sometimes the easier ones confuse people more. But I'm going to write 2 equations. Anytime I have absolute value, 2 equations. So the way to get rid of the 2 bars on the side is to write 2 equations. So I'm going to say x equals 10. There's my first one. Or my other answer is going to be that x equals negative 10. Now, this didn't have anything else to solve. Those are my 2 answers. When I'm asking you to graph the solutions, here's what I need. I don't even care if you put a 0 on here. I know that negative 10 is my smaller number, positive 10 is my bigger number. Graph a point there and a point there, and you're done. Take a look at number 2. X minus 4, or x minus 1 equals 4. So I'm going to start with my 2 equations. Again, to get rid of the 2 bars, I write 2 equations. So my first equation looks just like this. Just take the absolute value out. X minus 1 equals 4. The second equation is just going to be x minus 1 equals negative 4. Change the sign. And now these are one-step equations. You can solve this. Add 1 to both. I'm going to get that x equals 5. If I do that on the other problem, notice I'm not going to get -5. I'm going to get that x is -3. So they're not necessarily going to be opposites. I can check it. 5 minus 1 is 4, and the absolute value is 4. If I put in a -3, -3 right there, minus 1 or plus a -1 is -4, and the absolute value is 4. So for my graph, -3 is smaller, +5 is bigger, 2 points on the number line. And they're trying to trick you on number 3. The absolute value equals negative. Nope, can't do it. No solution. Now, you can only do that no solution automatically if the absolute value is by itself. We're going to have harder problems where you have to get the absolute value by itself first, but not today. So if you see any problems that are equal to a negative number today, they are just a no solution. In this problem, remember I said you're going to write 2 equations to get rid of your 2 bars? Is there a 0 and a -0? No. So we're just going to have the one problem to solve because 0 doesn't have an opposite. So I'm just going to have 3x plus 12 equals 0. This doesn't hardly ever happen in absolute value. They're just trying to show you that sometimes you're going to get someone that tries to trick you. So when I solve this whole thing just works out to be x equals -4. And we can check that, remember, so 3 times a -4, that's really a -12, plus 12 is 0, and the absolute value of 0 is 0. So my whole answer, this whole gigantic number line, is just for that 4 right there. This time I do need 2 equations. So my first equation is going to look just like what we have without the absolute value. Y plus 2 equals 8. The second problem is going to be y plus 2, don't change that, equals -8. We're never changing what's inside the absolute value. The 8 and the -8, that's the part that changes. So we solve these. And again, not opposites. We can get problems where we get opposites. It just didn't happen yet. So 6 and -10 are my numbers. So here's -10 and here's +6. And again, remember, this is saying actually -2 is my center on this one. If I was looking at this from -2, 8 units that way gets me to +6, and 8 units that way gets me to -10. Last problem. The absolute value of d over 3 is equal to 3. So d over 3 equals 3, or d over 3 equals -3. So I'm going to I have to really hurry because I'm almost out of time here, multiply by 3, and I get that d equals -9 and +9, which can happen sometimes. So your practice today is on a worksheet, just doing the evens, 2 through 16 evens. Make sure you show your work, and then make sure that you check, do the learning check, the practice problems, and then the formative quiz in Schoology. Good luck.